This is a briefing video for the amino acid modification experiment. So to start with, we've got the reaction scheme to show what experiments you'll be doing. So it's a two-step reaction. What you're going to do is start with the naturally occurring amino acid phenylalanine. You'll be using it as a racemic mixture. And then in the first step, what you'll be doing is you'll be doing an acylation reaction. You'll be taking that amine, reacting it with acetyl and acetic anhydride and to form an amide bond. And then in the second step, you'll take that intermediate and then convert the carboxylic acid into a methyl ester with thionyl chloride to help that process. So both reactions are basically sort of reactions involving forming an amide, carboxylic acid, reactions with carbonyl style functional groups, which you've been seen before in your sort of first year sort of theory modules. So you can find the mechanisms by looking back for your notes and also looking back at your first year organic chemistry lectures. The purpose of this experiment is to give you practice at getting re-familiar with a lot of your first year synthetic chemistry techniques. They're still going to feature quite heavily in a lot of the experiments that you'll continue to do in the rest of your course. And so the sort of all these skills are sort of the main skills that you'll be sort of repeating and practicing in this experiment. So setting up and heating a reaction and the reflux, doing a liquid-liquid separation with a separating funnel, recrystallization, recording melting points, using infrared and NMR spectroscopy to analyze the products. And so as part of the pre-labs, there are links to the pre-lab videos of all the techniques. And in particular, if it's been a long time since you've done these techniques and you feel that you're unfamiliar, then do sort of re-watch them to sort of re-familiarize yourself with what you need to do. And doing this will really sort of help ensure that you're more successful with the reaction, and also that you'll be able to complete the experiment sort of more smoothly and more quickly as well. Okay, so this is a sort of an approximate timetable for how the experiment should be sort of completed. So this will be experiment is going to run in your sort of first block of labs in the Priestley laboratory. So you've got 2.5 days to complete your experiments, and this is the first experiment that you should be completing. Step 1, the acetylation step, is quite a short step. I'll go through the details of what you're actually doing this step on the next slide, but it's anticipated that you should be able to complete this within sort of the morning. And then the second step, the esterification step, is one which you could potentially complete in the morning, but I think for most of you, you might just need a little bit more time on the second day to complete. So you should start it in the afternoon and then of the first day, and then you'll finish it off in the morning. And this is really probably an overestimate. I think you should be able to complete it within maybe 1 or 2 hours of the morning rather than necessarily needing 3, but that's a conservative estimate of how long the whole experiment should take. And then once you've completed the experiment, you'll then be able to move on to the other experiment that you need to complete or start in your sort of first block of labs. Okay, so this is a summary of the acetylation step that you'll be doing. As a reminder, you'll be starting off with the phenylalanine and then converting the amine into an amide bond. And so these are the steps of the reaction. Sort of doing the reaction, it's just simply mixing and stirring the reagents together at room temperature. It doesn't take long to complete. And then what you're going to do is you're going to sort of acidify the reaction to pH 1, and this will sort of precipitate out the product. Okay, and so you're using sodium hydroxide in this reaction. It helps sort of catalyze the amide bond formation. But what the sodium hydroxide is going to do is it's also going to deprotonate the carboxylic acid and convert it into a salt form. You're doing this reaction in water as the solvent, and so what it means is that even with the product that you form, you'll have the carboxylate form, and that will be sort of dissolved in water. So to help you isolate the product, you acidify this to pH 1, and that will reprotonate the carboxylic acid, and then your molecule becomes neutral again, and then it won't dissolve very well in water, so it precipitates out, and so you can filter it and isolate it as a crude material. And then what you're going to do is you're going to do purify it using recrystallization, again with water as a solvent. So it will dissolve, the product will dissolve in hot water, but it will sort of precipitate out in cold water. You might need to use quite a bit of water to get your compound to dissolve, but the key thing to make sure you don't use too much water is to make sure that it's really hot, so you use the minimum amount of water for your recrystallization. And then you'll have analysis at the end. Okay, the second step is the esterification, so taking the carboxylic acid of the intermediate and converting it into a methyl ester. And so this step, as I mentioned, wouldn't necessarily take sort of 6 hours, 2-3 hour blocks, but I would say about 4 or 5 hours. So the first part of the reaction is going to be a reflux, and it should be refluxed for 1 hour. And then following this, you're going to do a liquid-liquid extraction with a separating funnel. Okay, and it's probably the sort of first 2 stages where we think most students should have finished if they start this in the afternoon of the first day. Okay, so then the morning session is mostly about doing the following steps. The next step is called trituration. It's a little bit like recrystallization, but you don't have to heat up the solvent to get your product out as pure. So after you've done your liquid-liquid extraction and you sort of concentrate your crude product onto the rotary evaporator, you should get what is a kind of gummy mass. So your product is a solid, but because of some sort of non-polar impurities, it should come out as like a gummy solid. And so the way that trituration works is you're going to use a sort of non-polar solvent, petroleum ether. Okay, you're going to add a few drops of this to the gummy solid, and what that will do is it will sort of dissolve the non-polar impurities, but it won't dissolve the product because it's too polar in petroleum ether. And then what will happen is the petroleum ether is quite volatile, so it will evaporate, and as it evaporates, it'll evaporate off those non-polar impurities as well, and it should leave behind sort of a white solid for this as your product. So what you do is you add a small portion of petroleum ether, and then let it evaporate in air, or you can blow a bit of air onto it to help it evaporate, and then you should get out a solid. You might need to do this a few times for it to come out as a product. So add a little bit of solvent, let the pet ether evaporate, add a little bit more, let it evaporate. But within sort of 2 or 3 attempts, you should get out your product. And then again, at the end of the experiment, once you've got your solid, then you have your analysis. Okay, before you complete the experiment, do look through the hazards by reading the scripts. There will be sort of pre-lab questions based on the hazards of the experiments as well. Okay, again, it's okay if you don't remember all the hazards. Before you start the experiment, remember that they are at the start of the script. So before you use them, do check that you know what the hazards are, how you should handle them, and when you finish with them as well, what the safe way of disposing of them should be. In this particular experiment, perhaps the most hazardous reagent you're going to be using is thionyl chloride. Okay, it reacts really, really violently with water, and so you need to make sure that you handle this only in a fume hood, okay? And this includes actually weighing it and measuring it out in a fume hood as well. Okay, so if you're using a balance, make sure you put the balance in a fume hood, or if you're using the measuring cylinder, make sure the measuring cylinder is in a fume hood as well. Okay, and again, when you finish with it and you're sort of disposing of it by diluting it with water, make sure you dilute it with the water in the fume hood rather than taking it out and using the taps on the bench. Okay, and finally, these are some tips just to help you sort of do well on this experiment. Okay, and these tips all relate to maximizing the yields of this reaction. Okay, so obviously, as because you're doing this reaction in 2 steps, you want to make sure that you have enough material from step 1 to carry over into step 2. And one of the key things to maximize your yields here is to make sure that you're always transferring material from a flask to flask. So from your reaction flask to the separating funnel, from the separating funnel to your conical flask, from conical flasks to other round bottom flasks, etc. And the way to make sure you do this is to make sure that you always rinse out the flask that you've just been using with a bit of solvent and transfer that solvent into the new flask where all the material is going. Okay, so whatever solvent you're using at the various stages of the reaction, make sure you rinse it out with a small amount, maybe about 5 mils or so, about 2 or 3 times. And if you do that, you should transfer most of the material from one flask into another flask. And then a couple of tips to maximize the yields from each of the steps. From step 1, I think from the recrystallization, this is a part where you could potentially add in too much solvent, which therefore when you cool it down, you don't get all your product or as much product precipitating out at the end. So the way to ensure that you get as much material precipitating out when you cool your reaction at the end of a recrystallization is to use the minimum amount. So make sure that your water is hot before you start adding it to your sample that you're recrystallizing, and also once you start adding the water to your crude product, make sure you put the flask onto the hot plate as well, so you're keeping that water hot as well. And those 2 things should ensure that you use the minimum amount. And then for the second step, as I mentioned before, thionyl chloride reacts really violently with water. Okay, so if it reacts with water, it's not going to react with your intermediate, and therefore your yields will be lower. You'll get less of your intermediate converting into your product. So for the second step, before you set up your reflux, do make sure that your glassware, your round bottom flask, condenser, magnetic stirrer that you're using, even the pipettes, for example, make sure that they're all dry. Otherwise, they're going to react. Any water in there will react with the thionyl chloride and lower your yields. Okay, so that's the end of the briefing video for this experiment.